Hello everybody, this is John Cogley and welcome to my home. Today we're going to go over a couple of things. The biggest one we're going to go over is how to read a color chart. Many of you know how to read one, many of you don't. It's probably one of the best tools that you can have inside of your watercolor toolbox because it puts the power in your hands. So last week we talked about what we're going to talk about, and that was environmental friendly iron oxides. And the environmental friendly iron oxides come in three different shades. One is brown, one is red, and one is yellow. They're iron oxides, they're organic, they're from the earth. What makes these different is we purchased them from a company that's reclaiming them from where there was mining, and the streams around the mines were polluted. So there's a company that goes in and they dig up all of the hazardous materials. They send that to their plant. They process them all. They turn them into pure iron oxides without any type of other material in them, so they're perfectly harmless. And then they sell them to the world market. It costs us a little bit more to buy them, but the reason that we call them environmental friendly is that it helps this company reclaim the environment and make the streams once more safe. We've had it for about 15 years. Where we can, we always want to do our part to help the earth. Next week, what we'll go over is we'll go over the quinacridones. The quinacridones is a marvelous family of pigments. They're made for the car industry, and we'll go over those more in depth. So if you have questions about them, please post your questions, and I will look at those, and I'll add that onto our conversation next week. Hello, Sandra. Hello, Sharon. So let us start with the color chart. And I'm not real good at this. I'm going to see if I can turn this down to be able to see the color chart. This is what the color chart looks like. Again, quite large. And I'm going to take my iPad off so I can show you more clearly. Hopefully this works well. Okay. There's always a catch to everything. So for the color chart, can you hold this from the back here?
Yeah, it fell off. Huh?
No, I just want to show the people the color chart so they can see. You gotta hold it down so they can see the color chart. Yeah, it's almost like you have to hold like this. Okay, so this is the Daniel Smith color chart. And I'm trying to see that you can see that here. There's 260 colors. On the main section, we have our main colors. And then on the back, we have the Primatech. We have the Primatech. And then we have the luminescence, and these are the luminescence. So let's go over how to read a color chart. It's very simple, and once you have this down, it puts huge power in your hands. So the first one we're going to look at is going to be buff titanium, right here where my finger's at, buff titanium. And what we see about buff titanium is we see the common name, buff titanium, and then we see what it's available in. So this is available in 15 mil, 5 mil, stick, and in half pan. We look at the pigment name, pigment white, number 6, shade number 1. And then we see these letters right here, and they're super meaningful. We do that by reading the legend right here. There's a legend. And we're going to use this legend to understand the color. So the first, buff titanium, it says it's a 1. And the 1 stands for lightfastness. And in our legend, the 1 stands for 100 plus years, which means we've tested this on a xenon phaedometer to assure it will withstand sunlight for 100 years. The xenon phaedometer is a very large calibrated machine that can do 100 years of light in roughly 4 days. The next letter is also a 1, and that means for staining. So this is an example of a 1, 2, 3, and 4 for staining. 1 means you can pull the color right off. And I apologize for this. 1 means you can pull the color right off with a wet brush. 2 means you can still pull it off, but you see a little bit of color left. 3, more of it stays on. And 4, it won't move. So better. This is a 1. We actually pull the color right off with a wet brush because it's non-staining. 2, slightly more, so a little bit of stain. 3, much more staining. And 4, you can't pull it off. Very, very highly staining. So when we look back at buff titanium, it is a 1 because it can be pulled off. The Y stands for granulation, and whether it's granulating or non-granulating. If there's even the smallest amount of granulation, we put a Y to say it's granulating. The last one is for opacity, transparency. This one is semi-opaque. So once you understand those characteristics, very, very easy to read a color chart. So now you've seen what staining is. Let me show you opacity. So this is an example of opacity. The first color we see here is transparent. Transparent means you can see right through the color. The next one is semi-transparent. And semi-transparent, you can see a little bit, but not a lot. And then opaque. Opaque is totally, you can't see through it. That's going to matter when you're layering and how many layers you can do, for example, or whether you're part of a transparent watercolor society, which they want you to use transparent paints. So this is a very important characteristic to look at. So we're going to do buff titanium one more time. So buff titanium, we see that it is a 1 for 100 plus years. It's a 1 for low staining. It's a Y for granulation, and it's semi-transparent. So let's do one together. We're going to use quinethalone yellow. Right where my finger is, quinethalone yellow. So quinethalone yellow has a very interesting name. It's named by the chemistry house that produced it. If it's a single pigment, we give it the name of the creator, whether that's a person or a chemistry house. Quinethalone yellow is available only in 15 mil. It is a 2, which means it's 100 years. It is a 2, which means it is slightly staining. It does not granulate, which means the N, and it's semi-transparent. And the pigment is pigment yellow 138. The interesting thing about using the correct names, it allows you as a watercolorist to go to the web and actually look up the pigment, quinethalone yellow 138, and you can look at the characteristics. That might not be interesting to all of you, but some of you really love learning more about a particular pigment, and that's why we give it the correct name, is that you can look at all this information. Easily accessible on the web. See, you should a lesson in how to pronounce. So Angela says, I should give a lesson on how to pronounce some of the colors. You're right, some of these colors are very difficult to pronounce. Again, it's because we're giving them the name of the chemistry house or the person that created them, and most all of those are chemists. So The interesting now, you should be able to look at the chart and know about the color. If we look at azo yellow, for example, we would see what it's available in. It's a series 3. That's how they're sold. It's available in 15 mil. It's a 1 for 100 plus years. It's a 3 for a highly staining, a no granulation, and semi-transparent. So what does this teach us? What this really teaches us is that over a cup of coffee or a cup of tea, before I ever pick up a paintbrush, I can really know which paints I want to use and why I want to use them. For example, if I'm doing something and I want to be able to lift a color, I want to do, for example, and I want to lift pieces out of that wash, then one of the characteristics I'm going to look for is I'm going to look for a non-staining color, because I can pull that color up and put another color inside of it, for example. Say I wanted to do a lot of layering, I wanted to build up my painting. Then a characteristic that we would look for would be transparency. So we'd actually want to look at if we want to do a lot of layers, we would look for like a Aurelian. For example, Aurelian, where my finger's at, right here, is an open circle. And it's an open circle for transparency. Transparency, I could probably put 3 to 4 layers down. I could put 3 to 4 layers down before I had any type of opaqueness. Easily 3 and even 4. If it's semi-transparent, it's probably 2 to 3, and then I'm going to get mud, or I'm going to get some opaqueness. Whereas if it's fully opaque, it's 1 time. Okay? So my mother would always say to me, any paint, John, works for me. And that's not true, because the more you want to experiment in watercolors, the more you want to have the power over what you're using. If you're an oil colorist or an acrylic artist, then you could put black, wait for it to dry, put white, wait for it to dry, and you could play that game forever. You can't play that game when you're a watercolorist. You know as well as I that as a watercolorist, it's really taking apart an image. You're very analytical. You're able to pull the image apart into its components and then put it back light to dark until you finally hit opaque. That's what this tool allows you to do. It's a fabulous, fabulous tool. Okay, with that, Dawn is watching from Maple Ridge. Hello, Dawn. Can you come a little closer to the mic? Yes, let me come closer to the mic. I tried doing these and they don't seem to work really well. My new camera came, so next week it should be much, much better than today. I apologize for the sound quality. The one thing I did want to show you today is I wanted to show you Cascade Green. Cascade Green, if we look at Cascade Green, it's right here. Cascade Green, right there, Cascade Green. I know it's hard for you to read upside down. And Cascade Green is pigment brown number 7 and pigment blue number 15. The interesting thing is the pigment itself is a single pigment. Those two particles are co-precipitated, they're locked together. So chemically, it's actually one pigment. Hello, Lydia. And the neat thing from an artist standpoint is it can break apart and you can see the colors that make it up. And I'm going to show you that right here, right now. So we'll look at my paper here. Put a little bit of green down so you see it. Go. So you see it. There's the green. I'm going to get a water line. Now I have a green. Now I have a green rug. There we go, right there. I'm going to do a water line. And this color breaks apart really, really well. And after a while, you'll see actually some blues, some yellows, and some greens. It's a very, very interesting color. Of course, you need to put enough water to be able to see it in this. So it's a really, really, as it starts to dry, you'll see some yellows and some blues, and that's because it's a co-precipitated pigment. It's a really, really very interesting color. And if you have a chance to play with it, I would really recommend it highly. This is what it looks like. This is the Cascade green. Trying to make it see here. There we go. It's a very, very, very pretty color. This is the quinethalone yellow that we were looking at. Quinethalone yellow. I can make paint, but I'm not much of a video camera guy. I'm learning. So thank you so very much for putting up with me doing this. And this is the buff titanium. The buff titanium is quite a beautiful color. You can see the granulation. So it's a granulating color. It's very, very, very useful. So before I move on, did anybody have any questions about the reading of a color chart? Let's see, Brenda Brannon, I love the way Jean Hain uses Cascade Green. Jane's a master at Cascade Green. Christine, I use Cascade Green painted the Hawaiian mountains, and the mountains practically paint themselves. I love the color. That's beautiful. It's a beautiful, beautiful color. Angela, you're doing great. It's a learning curve. Thank you. That makes me feel good. Buff titanium is one of my favorites. That's Alice Gray. Yes, buff titanium is a very, very popular color. It's interesting. Debbie Cleveland, can you discuss the phthalos? Debbie, I will discuss the phthalos. I will put that, and I will discuss the phthalos next time. Absolutely. Yes, Angela says, can you give time frames for all the Lightfast levels? Yes. So on the color chart itself, it has the legend, and then I will go over it with you as well. The legend's right here on the color chart. Let me see here. There we go. There's the color chart, and there's the legend. So a one means it's 100 plus years. A 2 is 100 years. A 3 is about 40 to 50 years. And we only have 2 fugitive colors, and those are about 20 years. Now again, when I talk about, I'm talking about the paint in it's pure sunlight. There's no filter. There's no UV glass. It isn't in a room. That all increases the amount of time. So we test that with a xenon phaedometer. It used to be tested in Arizona with a slant table, and they would calibrate as best they could, because you're calibrating the sun, of how long a paint would last. With the xenon phaedometer, it's a scientific piece of equipment. We can test 100 years in about 4 days. So we test every color every time we make it. It's a very laborious process in which you need the machinery and the chemist to be able to read it. So 1, 2, 3, and so it's 100 plus years, 100 years, 65, 75 years, and the last one's about 18, 20 years, and that's the opera pink, which is a fugitive color, and that's the alizarin crimson. The alizarin crimson, you may know, is a coal tar derivative, coal, C-O-A-L, coal tar derivative. It is fugitive. We do have a permanent version. The interesting thing about the alizarin crimson, it's probably one of our best sellers. And you might ask yourself, well, why would people buy a fugitive color? And it's because the professors, who are extremely knowledgeable, want their students to use what the masters used. They tell them, the students know that it's a fugitive color. But behind UV, you're pushing it to a longer life period. That does come across as one of the questions I get asked quite often, and that is, if I have a fugitive color and I put that with one that's not fugitive, do I add the two together, divide by 2, and is that how long it would last? For example, do I take the alizarin crimson and it's 30 years and add that to a quinacridone, which is 100 plus years, and it's say it's 140 years, divide that by 2, is it now 70 years? No. The most that will happen is the high performance, high light fastness pigment might add 3 or 4 years to the fugitive, but not much more. When you're fugitive, you're always fugitive. You can never change a fugitive color. It's nature, and it will live to its nature. Sylvian loves the Ultimate Mixing Watercolor Set. Thank you very much. They're beautiful colors. They're highly concentrated colors. Each one of those little half pans is at or slightly more than a 5 ml tube. People ask me why, and that's because there's almost no water left because we dehydrate it over 5 times. How long do fugitive colors last again? I can only speak to our fugitive colors, which are the pink and the alizarin, the opera pink, and those last. Those last roughly 15, 20 years. Now that's in full sunlight. You put UV, and now you're talking triple that. You put it in a room that doesn't have full sunlight all the time in UV, even more. Yes, this is Claudia. Claudia, the alizarin crimson permanent is a permanent paint. It's 100 plus years. So we made that just so artists could choose to use the historic color, or they could use the permanent. Your choice as an artist. So the chemistry different. The alizarin crimson is a coal tar derivative, and as such, it's not a very it's a very bright pigment, but it's not a long-lasting pigment. Whereas the permanent is more than one high-performance pigment mixed together. That gives it its permanence. Angela talking about opera pink, she can't live without it, and also moonglow, quinacridone yellow, and lunar black. Those are all beautiful colors. Do you still have the color maps that you printed years ago? No, we don't have those. We're working on new color maps. We want to provide a tool that allows you to look up our colors. The color map, the color sphere for us is a 360-degree sphere. So while it looks very two-dimensional on a piece of paper, inside it's actually a sphere, and we're putting how far and how close the colors are to each other, what are their complements, etc. We will have that. We're working on that now. That was Sharon. Tina Mayer, I adore your paints. Thank you very much. There's a lot of paints to adore. We're at 260. Hematite burnt scarlet brings me so much joy. It's a beautiful natural color. The hematite, the burnt scarlet, they're beautiful colors. Is it possible to come up with a bright, like opera, that will not be fugitive? This is Carmen. No, Carmen. Realistically, when something is that bright, a neon, etc., they're going to be fugitive. You don't see that brightness in nature, and so therefore it's going to be synthetic. And there isn't a synthetic pigment that isn't fugitive that would be that bright and that vibrant. What about Cascade green causes yellow shade? Just more raw sienna? What about Cascade green yellow shade? We only have one flavor of Cascade green, but it's a co-precipitated pigment. And what happens when you add water, it actually breaks that pigment into its two pieces, which allow you to see different colors. I will explain the history of manganese blue at our next session. I'll write that down and make sure I do that. Raffaele. To Mark. Genuine. Daniel Smith colors. Daniel Smith has love for many in India. Thank you for making what beautiful watercolors. Thank you very much, Tarun. I appreciate it. Fabulous artists in India. Our red jasper is the newest color that comes from India, and I'm glad to have it. You know, I love your paints. Can you please make an orange with pigment orange number 71? So when we make colors, and we make colors all the time, we're always going to the car industry, which is the biggest provider of pigments, and researching pigments. We probably have 10 to 15 per month come in. The difference becomes, and you can kind of see it within the color chart, is if we're going to make 4 yellows, we want them to be different. For example, one might be granulating and the rest might not be. One might be opaque, one might be transparent, one might be semi-transparent. We never come out with the same color that has all of the same variables, otherwise it's just the same color. Love geeking out on technical information. That's Lydia. Me too. I love the chemistry. I love the physics. I love what you as artists can do. I'm always amazed. You amaze me constantly. I love the things that you talk about. I'm so disappointed that I and you can't travel because I really miss the energy that all of you give. You have such a phenomenal amount of energy, and I just absolutely love it. I'm sure it's the same thing a teacher gets when they're teaching 5th graders and 8th graders, that unbridled energy. And no matter how old you are, you guys have it. You have that unbridled energy that I just absolutely love. So I miss that. Jane Blondell, replying to Ian for transparent pyro orange. Jane Blondell from Australia is not only is she a wonderful person, she's extremely giving in telling people about pigments and also how those pigments work from an artist standpoint. Absolutely wonderful person. Red Jasper is a recent addition. Yes, it's a recent addition to the Primitive series. When I was traveling in India, my second time, I saw it everywhere. The men were working on it, making carvings, and it's in a lot of the monuments. It's a very, very beautiful, subtle pigment. I've learned so much from Jane. Yes, Jane is marvelous. Agnes, yes, I'll be missing everybody. A lot of us were supposed to meet. Yeah, we were all supposed to meet in Fabriano and Urbino. So, and then all places in between. So I will miss that as well. I'll miss seeing all of you. So next week we'll be going. I'll review some of the questions you asked, and in addition, we'll be spending some more time on the quinacridons, which are a beautiful family of 5 ring structures that make up that very, very unique color. What percentage of the auto industry pigments do you think make it into the art material world? Quite a few. Quite a few make it because several reasons. One, for the automobile industry, they have to be pretty much indestructible. So they're very, very high light fastness. From a pigment shape standpoint, they're absolutely perfect. Nobody wants a granulating car. So they're very, very, very beautiful colors. We constantly look at pigment that's being made available to the automobile industry all the time. So quite a few, many. The quins are from the automobile industry. The parallenes, automobile industry. So a lot of the colors that we have within our range are from the automobile, or would go to the automobile industry. They're absolutely gorgeous. Misha, hi everyone. Alice Gray. Alice, I will get back to you on some of the books that I look at. So Jane is talking about colors. Debbie Cleveland, why no quin blues? You know, quinacridones, and I'll go over this next week, the reason there's a color shift is how the ring structure moves. And quite frankly, when we look at colors, we look at a lot of colors. In a given year, probably at least 100 different new pigments. They don't measure up. So we'll send them out to our test group of artists throughout the world, and we'll say, what do you think about this? And if they can't get back to us with why it would be useful to bring it out, then we're not going to bring it out. They just stay in our laboratory, and that's just where they stay. So everybody has their beauty. Some people love the synthetics. The synthetics are gorgeous because they're pretty much perfect. And then there's the organics, the naturals. And those pretty much behave the way they want to behave. They're it's kind of the boxing versus the martial arts. I will get back to you, Babit, on the PO71. What I do is if something has changed or will change within 2 years, I will let you know. So you're way ahead on whether colors changed. But a lot of things can cause a color to change from using it from the tube. How much you're putting out, for example. There's different aspects. Okay. My assistant's holding the camera for me. She's doing such a good job. There we go. All right. Please, if you think about something, please go into the video and add your question. I love questions. There's no bad question. I feel really good when I can answer your questions. It's even better when you stump me. I love to be stumped because then I get to learn too. So please ask questions. Absolutely love them. Sticks versus pans. Are there quality differences? So whether you're using our tubes, our pans, or our sticks, it's all the same exact pigment. Exact. The sticks are made without using any type of binder except the gum arabic. So they are a huge amount of pigment. They are not dehydrated to the same extent that a pan is. A pan has less than 11% moisture, as condensed can be. Whereas a stick has very little moisture. There's just a huge amount of material. And we made it that way. The difference really is how they can be used. A stick can be used as a drawing device. It can be used, you can paint off the tip of it. There's many ways to use a stick. If you cut the stick and put it in the pan, you could use it that way, but it's never going to have the same it's not going to have the same water level. They're made differently for usage, but they're made the same in terms of the pigment, etc. Any new ideas for semi-old dried paints to make them smoother again? I add gum arabic. Well, there's 3 ways that you can do something to a paint to kind of renew it. Once it's dried out, however, there's a limited amount. So let me tell you the 3, and one of them I do not suggest. I will tell you about it, but I do not suggest it. One is to reconstitute using distilled water, drop by drop. And the reason that is absolutely the best is you can always undo it. You just let it go back and dry out. As long as you don't add too much distilled water, because then you'll break the binder from the pigment. The next one is using, as the artist said here, is using gum arabic. You can do that. The third is using oxgall. I would not suggest this. We don't use oxgall. Some people do. It acts as a flow releaser. I'll just mention because it's a third way. It's absolutely the worst thing you could do. So I do not recommend it. I'll just tell you from an academic standpoint. The number 1 way is with distilled water. And if it's a really good paint like Daniel Smith, if it dries out, that's not a big deal. You just re-wet it with some warm distilled water and you paint away and let it dry out again. Raffaelli explains the same thing I would explain is if a tube dries out, you can always open the bottom of the tube, take away the saddle crimp, and wet it, or you can cut it open and you would just have a massive pan in the shape of a tube. But use distilled water because you can always come back. You're not adding anything to the paint. It's the easiest way to come back, and it's very, very cheap to buy distilled water. German greenish raw umber. Can you tell us more about the name? This is Giovanni. A lot of the names are historic names, and if it's a historic name, we'll actually use the name. But I will write that down, and I will tell you more about that next week, Giovanni. Lydia, that's a beautiful color. It is a very nice color. Okay. Let's see if I get some more questions. Otherwise, I'm going to write down the questions that you have, and I'm going to go over those next week. Yeah, the reason, this is Lauren McCracken, and would I recommend painting with distilled water? Yes, I would, and that's because we're all in different countries. In the United States, we're all in different states. My sister, who lives 100 miles away from me, lives on a farm, and they get their water from a well. It's going to have different types of metals in it. It's going to have different types of chemicals in it. Whereas here in Seattle, mine has fluoride and chlorine. If you want to take those out of the equation, and as an artist, you always want to limit your variables. You always want to use the best equipment you can, and also limit your variables. The reason you want to do that is you want to work on your expertise. You don't want the paint telling you what to do. You don't want the brush telling you what to do, and you certainly don't want the water telling you what to do. So to get back in the same place, distilled water is best because there's nothing else in it. It's readily available. It's readily available at any of the million pharmacy stores or supermarkets. So it's very, very easy to get. Why do my nickels so yellow shimmer? I don't. Linda, let me think about that. I'm probably a little bit more specific so I can answer your question better. Barb, thank you. I love doing this. Again, I really want it to be something that allows me to answer questions that you have, that allow you to put the answers in your toolbox and do more with your artwork. It makes me feel great. You have great questions, and I really appreciate so much that you use Daniel Smith product. Folks ever go back to online supplies? No, this is from Carmen. Carmen will never do that because we're here to support the brick and mortar stores and the online stores that support you. So as a manufacturer, I never want to be in competition with them. That's something I'll never ever do again. I close my internet, I close the catalog to fully support the brick and mortar who better support you because they're local to you. Maestro Che, hello. It's my pleasure supporting the stores. You as artists and the stores have been so good to us as a company. It's wonderful that we're a 43-year-old company. It means a lot to me. Do any paints oxidize? It's difficult for paints to oxidize, even when you're using iron oxides, and you know, whether it's the environmental friendly oxides or the Primitex, many of those are oxides. However, they're what's called encapsulated. As the gum arabic goes around the particle, it is encapsulated and the air is not hitting it. So it would be very difficult, if not reasonably improbable, to oxidize. The only way it would oxidize if you used just an incredible amount of water and you took the binder away from the particle. And even then it would be very difficult. Paints and Frimmins in Tulsa are great stock. Ziegler paints, very good in Tulsa. I'm so sorry I no longer live in Tulsa. Yeah, Tulsa's actually a very nice place. I kind of like Tulsa. That's Tulsa, Oklahoma, USA. Very nice place. Thank you, Sandra. Okay. Well, I'm going to wrap up. Please, again, leave your questions. I will read them. I will put them together, and I will either get back to you directly or I will answer them online next time. Why do you call these paintings environmental friendly? You may have missed when I started today, but they're called environmental friendly because we buy them from a company who goes to Superfund sites. These are sites that have been contaminated. And in the US, one of the biggest contaminations is from mining. There was a lot of mining in the US, certainly in Arizona, Utah, etc. This particular company goes in, they clean out the streams, they take all that metal, all that stuff out of the streams to make it once again vibrant and healthy. They send that material to a very big pigment company who purifies it and makes it available for sale. They take out anything that would be hazardous. They take out anything that would be bad. So it's just pure pigment. I pay more for that. And part of that money goes back to the people to allow them to clean even more streams. That's why it's called environmental friendly. I could buy it for less from people that make it who don't do that. It's our part helping clean the streams in the United States, and we try to do it in other places in the world as well. It's kind of paying it forward. Caroline Debbie, welcome. Almost done. It's been very good. Thanks for sharing your knowledge. I love sharing my knowledge. Thank you for allowing me to share it. So with that, I'm going to wrap up today. Next week, again, we're going to go over the quinacridones. I know that you love quinacridones. So if you have any questions about the quinacridones, please send them to me so I can add them into our discussion for next time. Thank you all very, very much. I love your ideas, so let me know some other things that you would want to know about. A quick question just came across. Do you get less granulation with distilled water? No. A pigment will granulate to the extent it's going to granulate. While the water doesn't matter for that particular effect to happen, it's just better, where possible, if you're working on your technique, to use the distilled water because you know you can always get back. You know it wasn't because the water had a metal or a chloride or a fluoride. So you can always get back to the same place. But of course, like my mother would always say, using whatever water is up to you. You're the artist. You're in control. Thank you all very much, and I look forward to seeing you all next time. Bye-bye.